A warm welcome, a good afternoon to everyone. Thank you for joining today's webinar. Today I am live with AWS User Group Punjab, and the topic is going to be Introduction to Serverless. Hope we have going to be having a great fun throughout the session and a great learning opportunity. So let me move on next with a quick introduction about myself. My name is Sanchit Jain. I work as a lead architect at Quantify. I'm an AWS ambassador, and there are different ways you can reach out to me. You can ping me on LinkedIn, Twitter, or on GitHub. I'm active in all the social media platforms, happy to support any community initiatives or any discussion you want to have about your career. So please reach out to me and let me know if I can help in any help of you. Today's agenda, as I talk about, this is going to be more around the serverless, and today's agenda is going to be introduction, what exactly is serverless all about, a quick demo to Lambda. Then we'll go through the code walkthrough, how exactly a Lambda code looks like, what its constitutes are, SQNS, SNS, a quick demo around its step function, and last at the demo, right? Generally, when it comes to serverless, here are the different services, what we look around, a limited handful of them like Lambda, S3, API Gateway, DynamoDB, SNS, step function, event-driven SPS, right? These services are couples or integrates with each other to help us to build a serverless kinds of technology. That's what will be our agenda in these different sessions, what we are going to have today and in upcoming duration, where we're going to talk about all of the services as well, a quick demo which constitute around the services. So first, let's jump to the understand today's agenda, and let's understand what exactly is serverless, right? So serverless, generally from a name itself, we can easily identify. Serverless means serverless. There is nothing server behind it, right? Ideally, yes, that's the correct definition, but let me call out some hidden facts about it. That's not true. Serverless is a true serverless for as an end user. If I am the one, I'm the end user on AWS, and for me, it's serverless because there is nothing, no server, nothing gets pinned up at my account. But at the backend, if I talk about, let's say you are working on Lambda, then at the backend, there is a server that gets pinned up, which is on the AWS side of it. They takes care of all those operational and other activity. You as an end user have to just only worry about your code. That's why it's serverless with respect to the end user or perspective of mine as an end user. That's what the key difference is. Which generally people don't clear it out pretty here. That's one. If you go around to the definition of what exactly serverless is a cloud native platform. Cloud native means that as an end user, I don't have to do anything. It's native to the cloud provider. In our case, it's AWS, Amazon Web Service. It's native, cloud native to AWS platform. And then when you should use, right, a cloud native platform for short running, stateless computation and event-driven application, which scales up, scales down instantly and automatically, and charges for actual usage at a millisecond granularity. This is a very simple definition around it, right? And if you go through this definition, it will clearly talk about what exactly is serverless and why there is a boom of serverless, right? It's pretty simple. It runs for a short duration, stateless computation, and an event-driven. Scales up, scales down automatically, and charge for what you pay, right? So you don't have to worry about scaling your infrastructure. You don't have to worry about the cost around it. You don't have to worry about it. Who's going to execute my Lambda when something goes wrong, or who's going to invoke that service? It's event driven, so it will be taken care. And it's a short duration, right? So only as you pay, let's say if you're executing a Lambda for 1 minute, so it's only going to run for 1 minute, not for the entire 24 hours or not for the 1 hour, right? So that definition of serverless itself is very clear, that can help you to understand what exactly is serverless, right? And on the right-hand side, as we can see, the different benefits on a high level: greater agility, less overhead, better focus, increased scale, more flexibility, and faster time to market, right? So these are pretty obvious that you get quick agility to work around, because in serverless, you only focus on your business application. Very simple. If I talk about a person who's already working on AWS, you don't have to worry about my server is going to increase or not. If it get increased, what will be the idle number around it? Do I have to pay more cost of it? What happens if something goes wrong around it in terms of scaling and all those activities, right? So that, all those operational things goes aside, and you just only have to focus as a developer, whether my code is going to execute correctly or not. So that gives you greater agility, less overhead, and better focus. You're only focused on your application rather than worrying about the infrastructure part of it. Increase with scale. Let's say it's pretty easy, right? You deploy one Lambda, that Lambda itself will take care to even go to up to 1,000, 10,000, or a million of users. You really don't have to worry about that, whether it's going to go to millions of users or not, right? By doing load testing and all. For sure, you need to ensure that your code written or deploy in Lambda is up to the mark. But when it comes to infrastructure of Lambda, AWS takes care of it, which gives you more flexibility. And at the last, that allows you to reach to the market in a faster way, right? So in a general, you build an application on any compute like EC2 or any other stuff. The time to build that application, the time to test, the time to deploy that application, it takes, let's say it takes 6 months. For an example, then similar application, if you can deploy in Lambda, if it is a short duration, if you deploy in Lambda, it will take less than that time, which will be somewhere around like a month or two itself, because that operational overhead get eased out when it talks about serverless. Why serverless is attractive? I think in the definition itself, we were able to connect the dots, right? First, serverless means no server. I think I have already covered that point in the last slide, right? Exactly. Serverless means no server or very less about the server. Ideally, serverless means no server for as an end user, and it's about the AWS, there is a server, right? So for me, it's no server around it. Second, run codes only on demand as per the request. As we understood, it's more event driven. So you only have, the code will only execute when there is event. Now it can be multiple approaches, right? It need not to be always that event can be automatic generated. Certain times people also schedule the event, like you say, like how you have an alarm in your phone. Similarly, you can schedule the events that, okay, hey, you generate an event at 2 a.m. morning, and that should invoke my Lambda, right? There are certain activities you need to perform. So events doesn't mean that it has to be automatic. Sometimes you manually also schedule the events and let them run. Third point, making app development ops dramatically faster, cheaper, and easier. As we talk about, right? You only have to focus on your application development and need not to worry about things like operational load testing and all other stuff, right? It gets simply dramatically reduced. Last, drive infrastructure or cost saving, because you're only paying pay as you go, which is like, I would say, thumb rule of any cloud services, that you pay what as you go. So it's going to give you that infrastructure saving, right? The key important thing in this slide is this table. So generally, as an user, if you're working on-prem, you're working on any of the cloud platform, couple of things. This is a common compute platform where you deal around it, right? You have an on-prem, let's say any servers, which can be as simple, let's say your machine or any other machine running which physical machine. Second is a virtualized machine, VMs. Third is the container, those all Docker, Kubernetes and all. And then the last, what we have a serverless, right? If we try to compare all these 4 compute platform against 3 factors, which is time to provision, utilization, and charging granularity, you will see that serverless always stands effective compared to all those 3. Like I have heard personally that in scenario by scenario, containers works pretty well compared to serverless, compared to VM, right? I will also help you where exactly that scenario is, where containers outstand compared to serverless and why so. There is a reason behind it, which is very important to understand. But if we go for any short-lived application, serverless is very effective and always outstand compared to rest of the 3. This is the same representation if I talk about in an AWS fashion. We have bare metal, we have Amazon EC2, Amazon ECS, Amazon EKS, and Amazon Lambda, right? If I talk about on the y-axis, we have the focus on the business application. On the x-axis, what I have the decreased concerns over stack implementation, which is like operational activities. If I compare on both of these graphs, you will see Lambda always holds on a very higher ground compared to rest of the other compute platform, followed by the entire container technology, virtualized VM, which is EC2, and at the last, the bare metal, right? If we go from, let's say, from top to bottom, in Lambda, you always have to focus on the application, as we understood. So you're not worrying about the operational or any of this stuff. So that gives you more focus on your business application and lesser worry about the application implementation, right? SAG implementation. That's why it holds the highest precedence here. When it comes to ECS and EKS, because of the way they share the stuff, and you don't, the step across the application and a layer above the virtualization, that allows you to focus on the business application and implementation better than Amazon EC2, but not compared to the Lambda, because you still have to worry about the operational part of it, testing and all of this stuff. Amazon EC2 instance, we all know about it. Reliability is what we need to look forward. It should auto scale around it. You have to do proper load testing and all, which has its own strength. But compared to if you talk about in a pure serverless fashion, it lags behind. And bare metal, I think we all know about it. There is multiple kinds of effort that needs to be invested from terms of cost, time, and resources in order to ensure that you do get those things what you're looking forward, right? So that's how Lambda always stands effective when you're talking about or comparing in the other compute platform. Now, I have spoken a lot about it's an event-driven. You only have to worry about your business application. No need to worry about the operational overhead. Let's understand one level down to it that, okay, we are all sold. Lambda is the go-to tool for us or go-to service of us. But how exactly Lambda works, right? Or generally a serverless function works. So this architecture or this flow will help you to understand in a real-time scenario how this dots which are open-ended gets connected as one application or one pipeline and gives you the desired state or that desired application. So I've spoken about that Lambda runs in response to an event. It's an event-driven programming. Okay. Now, what exactly is an event? First of all, let's understand that from the left side of it. So an event can be anything. Okay. I'm explaining you something is also an event. Okay. Your server got crashed is also an event. Someone upload a file in S3 and also an event. Any action that takes place is an event in a simple generic term. That explanation, if you took it on the cloud, right? Anything which happens, any activity which happens on the cloud is an event. That's a simple explanation I can give about when it comes to event. Now that can be anything. Someone drop a column from a database. Someone inserted a new record in a database. Someone upload a file into S3, or let's say someone destroy or terminated an EC2 instance, intentionally, unintentionally. But everything is an event. Whenever an event generates, if you have classified or if you have mentioned in the Lambda that if XYZ events generates, then capture and executes, right? So what happens, let's say for an example, you have a production environment where you want to be sure that whenever an EC2 instance get terminated, you want to send an alarm to your entire DevOps team. So what you have done is you have configured an event in a CloudWatch in Lambda to ensure your wire up that, okay, if someone is constantly hearing that, is there any event of termination that occurs from EC2? Let's say some fresher who just joined your organization coincidentally, this terminated an EC2 instance, right? Now, what happens is whenever that person terminates an instance, there is an event generated. There are things like Event Bridge, CloudWatch, which and with help of CloudTrail, capture that event quickly that, okay, hey, something got occurred spontaneously with terms of termination. They give that event, send it to Lambda based on the code which is written in the Lambda. As I mentioned, we need to send a notification, email notification. So as soon as CloudWatch gives or invokes the Lambda, it sends that event that, okay, XYZ person has related XYZ instance. Lambda receives that event, the code which is given in the Lambda, which can be in any language, Node.js, Python, Java, C#, Go, Ruby, any of the runtime APIs. That exactly is your business application. Like in response to an event, you're going to take an action, and that action will be anything, which is on the right-hand side. That action can be you preserve into database. That action can be you send an email notification. That action can be you can patch, right? So if I talk about a general scenario, generally Lambda is widely used in terms of remediations, security remediations. Like if I talk about one of the use cases which I have worked on is currently cyber security is on the topmost. So if someone unintentionally goes to firewall or security group, adds an IP address which is 00, immediately Lambda gets triggered and delete that particular rule, as well as sends an email notification to the person who made the change, as well as to me as an owner that this person made a change, so I can go and talk to him what happened. This was a very small utility, cost effective, but it helped me to at least preserve the 90% of attack that used to take place, and which was more in this COVID phase because everyone was working remotely. Such kinds of small, quick remediation utilities you can develop. I mean, this is one of the examples. There are many more we are going to learn in this session, but such kinds of small applications you can build with help of Lambda and this event that can help you to achieve anything in your absence. because you cannot sit throughout the day to keep observing what's happening and what time, right? And what about midnight? At the middle of the night, someone just goes and makes some changes. So there, Lambda works pretty well. And with the help of event-driven, it's actively listening to the changes which you have configured for it. So that's about how triggers code execution works. Next, what we'll do is we'll quickly run through the demo. I forgot to mention around it, the presentation which I'm highlighting on the screen, I'm sharing on my screen, as well as all the scripts, which I talk about a very simple Lambda to a cloud formation. All I have uploaded to a GitHub repository. This is a public GitHub repository, which will be shared by the user group along with the session. So you need not to worry. If you want to try this out at your own, or if you want to share it with a larger audience, feel free. This is for the community. So take the maximum benefit out of it. As a next, what I'm going to do is, first, step one is you have to go and launch a prerequisites, which is download a CloudFormation template from the link. This link points to my GitHub repository where there is a CloudFormation template already resides. So we focus on the demo part rather than really worrying about what is the CloudFormation and all. Once a CloudFormation stack is deployed successfully, please capture the role name. So what I'll do is I'll switch to my AWS Console. And here I'm going to do the CloudFormation. Let's say if someone are attending this session for the very first time and you're pretty new to the AWS Console, don't panic. You can directly search. That's the best part of Amazon. It's very user-friendly. You can directly search the CloudFormation in the search bar and you will get the same thing. If you have someone experienced, then you can directly, how you have to find the CloudFormation service. So also, just to say, I have uploaded this CloudFormation template already in my desktop, right? So it's already there. What I'm going to do here is, so CloudFormation template, this is on my desktop CloudFormation template, which is there. I'll click on next. Next, let's say I'm giving a meaningful name to it. In meantime, this CloudFormation runs. Let me give a quick precursor. CloudFormation is the infrastructure as a code. For the guys who doesn't know about the CloudFormation, it's a way to automate the things when it comes to the infrastructure, right? So let's say now there are two options I would have done. I would have manually gone, I manually go through the IAM console and try to create an IAM role, which are required for the Lambda, or I can just squeeze everything, package it in CloudFormation, and I can reuse it every time, right? So I always prefer CloudFormation because that helped me to focus pure on my demo rather than the operational part of it. So that was a quick precursor for all the folks. Here you will see that this particular CloudFormation, if I go to the template part of it, it's going to only focusing on things like creating the policy for Lambda, and then attaching the policy in the IAM roles along with the other AWS policies, and finally giving me an policy ARN, which make me ensure that, okay, this is a policy I need to attach on the Lambda. This is going to be very fast. Yeah, as we can see, it's almost done. And from the resource, you can see there will be a role and a policy which got deployed by this CloudFormation. And in the output, we'll get a role name. This is a role name, what we need to attach to our Lambda function. Okay, so far, I hope you guys are doing good. What I'll do the next step is I'll open one more window and I'll go to the Lambda console now. So I'll directly search a Lambda here. And you can see the first service itself under service section, you can see a Lambda. Please ensure that you go to the service sections itself, not the feature. So here we will deploy a Lambda function. It's more like an hello world Lambda function, which will be based on Python. Python 3, any version, right? So for example, as I've already deployed for my demo for a dry run, we'll deploy one more. So I'll click on create function here. There are multiple ways you can play around with the Lambda, right? You can use a blueprint, which is provided by AWS. There are many of such blueprints are given around it. You can also use a container image. Recently, I would say a couple of months ago, AWS announced container support that you can deploy the Docker itself in the Lambda Docker image. So you can also use the container image around it, or you can use serverless application repositories around it. This is a kind of a repository where community folks do upload their usable code into this Lambda in this repository where you can access and you can just worry about it. I mean, you can leverage that. In case if you don't know about Lambda, you don't have to worry. You can leverage this of the starter guides and you can look forward. So I'll give a name to it, serverless. Okay, as we were talking about the different environments, right? So there are multiple different environments that Lambda supports. .NET, Go, Java, Node.js, Python, Ruby. So for our case, we will be using Python, but you can see all the different, these are the major category, and these are the different versions of those environment Lambda supports, okay? What you're going to do is, we are going to give an IAM role to it. Now you can create a new IAM role. You can use an existing one. You'll select an existing from the drop-down, select serverless. This is same cloud for same IAM role. We deployed via CloudFormation. Next, in the advanced settings, you can ensure that this Lambda can access all the services within the VPC, or you can skip it. For this demo, I'm not going to make any changes in the advanced settings, and I'll click on create function. So once on function is there, this will be a very simple skeleton of code, which is like an hello world example, a starter example, which will just take an event and print hello from the Lambda. What I'll do is I'll first for sure execute this so you guys can understand what I'm just trying to. Okay. Let's say I just give okay. So this was an event JSON, which is there, right? First of all, this event JSON, if I go and run it, you can see hello world, right? Whatever the input is. So whenever I click and give a test input, it prints an hello world from the Lambda. So this is a very, very basic, I would say, starter implementation. For the demo, I've already designed a Lambda. So I'm going to switch to my desktop and we're going to get this Lambda, which again, I'll post it into our public GitHub account. So this is a simple, very simple Lambda. It's going to take 2 numbers as input and going to perform a couple of arithmetic operations on top of it, like sum, product, differentiation, quotations, and all. Okay. So after every change, what you have done, how do you, I mean, in local machine, how you save your work, here you need to deploy that changes. Deploy is like whatever changes you have done get deployed in Lambda behind the scene. So then you can test and Lambda will be executing the latest version, right? So now, since I have changed my Lambda code, from this right-hand side drop-down arrow, I'll configure a new test event. Okay, I'll select a new event, and the test event also I've given into our GitHub repository, which I've downloaded locally. This is a test event, so you don't have to worry about even the test event I've given. I'll be accepting 2 numbers, number 1 and number 2. Let's say I make a change as 30 and as 40, okay, in the Lambda. And I click on create. So by default, please ensure that you're selecting the right event from here. The pointer shows it is pointing to demo event, which is fine. Now we'll click. As you can see, immediately it gave me 2 response. This was an input which I gave, and this is output for it. That's correct, right? 30 plus 40 is 70. If you multiply, it's 1,200. Then there's a difference around it, and there is a quotation, right? So this is around a quick demo, I would say, in very hello world. Okay, this is more like an hello world example. There is much more complex application what you can build with different programming language and different demos around it, right? So which need not to worry about it. We'll have all those exhaustive list of demos and complex application to be followed up in the next sessions. But for now, this is a quick demo Lambda, where we talk about how exactly you have to work around the Lambda console, what things you need to worry about, and all this stuff. Last, I will also demonstrate one more thing before we continue with the presentation. There are some additional configuration what you can do, like memory. Since it is a serverless, you need to define what memory you need for your Lambda and the duration. It was a very small demo, small quick application, so I've kept it 3 seconds. But based on your application, you need to define or allocate the right memory and right timeout. As well as you can also ensure that, let's say, if I want to see the logs at how my Lambda is executing, that's very important, right? You can go to the monitoring section where you can go check in CloudWatch, you can have X-ray, or you can have Lambda Insights. These are the 3 ways you can get more detail about how your Lambda is executing. Is there any scope to optimize? How exactly each and every function with the Lambda is doing, right? Honestly speaking, I love the X-rays. It's the best thing, right? It's not only just giving consolidated metrics, like, okay, how your Lambda works, but on each function, each statement, how you can configure it can give you the inputs, right? Like up to very granular that, okay, how much time it takes to read a message from DynamoDB, or let's say download a file from S3. Those kinds of granular operational view also is provided by X-ray if you configure it in the right way. So that's about this quick demo. Now I'll switch back to my presentation. So we perform a prerequisites, which was around the cloud formation. Second, we created a function around it. We provided the function name. We provided the kind of a runtime. Here we have used 3.9, and we have used the IAM role, the same IAM role, which we got from the cloud formation. And the last, we configure the Lambda. The code, as I mentioned, is already given, pointing to my GitHub repository. This is an event, which again is given in the GitHub repository, and you can test the output. So that was about the demo. Let's understand. The more important thing for me to keep this demo short was to understand what exactly this code is, right? I mean, whatever this line of codes I've written, the line of codes I've written here, right? If you go here in this Lambda, what exactly each line of code is there? What is common that you always need to have in Lambda versus what is my business application, right? That's exactly is the more important thing to understand rather than having more demos or more hands-on around it. So in Lambda function, if I talk about from a coding perspective, there are 3 things you have to worry about it. Handler function, event object, context object. Handler function is more around your function which get execute, the parent function which will execute the first entry point in your Lambda, right? Whenever a Lambda get invokes, what is the first method? So people like who are pretty good in Java, you always understand public static void main, right? Is the first function or method which get execute when a Java program starts. Similarly is the handler function case of Lambda. Whenever Lambda executes, handler function is the first one which has been invoked by Lambda. And then you can have different smaller functions, or you can have the entire code bundle up in the handle function. Honestly speaking, you should not do this later approach. You should always break down your code into different functions, which gives you more readability. Second is the event object. Now, event object, we spoke about the event, the different change in state, actions. That all thing, that entire message is passed on to Lambda via event object, right? Which can be anything, an S3, SQS, SNS, any of the event in the form of an event object are given to the Lambda or feed it into the Lambda. Context gives you more management or operational information about the Lambda, like things like request ID, log group, how much time the Lambda still can run out of that duration. Those kinds of management kind of an information you can get from the context object. So ideally do remember handler function, event object, context object. These are the 3 important things which you need to configure whatever, or in any case of Lambda you build in any programming language. It doesn't depend, even if you go to Go language or .NET or Node.js, these 3 terminologies remains the same. So even if you go and check our Lambda function which we have developed, you can see it's the same name, right? You have this my handler function. Okay, you can name the function anything. It need not to have a specific handler as a keyword. You can name anything, but there has to be a handler function, there has to be an event, and there has to be a context. Again, it's very important. Someone can ask me that, okay, hey, as you mentioned, Lambda, you don't have to specify the handler function. Then where do you define that, okay, this XYZ function is going to be a handler function? pretty very good question, I would say. Here, when you're configuring the runtime settings, right? Since I use a kind of a inbuilt design template of Lambda, so I don't have to configure the handler. But when I was configuring the runtime Python 9.7, in that setting, I also defined that, okay, hey, Lambda, this will be your handler function. So please ensure you invoke this, right? Lambda function name dot handler function. So this is, in our case, this is a Lambda file name dot Lambda handler. So whenever you're configuring, let's say what I have done is manually playing on the console. There are people, when you're actually working in any industry use case, what you generally do is you don't play around with the console directly. What you do is you have a zip file, and via help of that zip file, you upload the code. So it's very important when you're doing such, you have to explicitly provide the handler function. So in that case, the handler function is going to be the file name, which is your Python main file dot the function name. So always watch out that you have a file name dot function name. So that's how you can specify the handler. Okay. So if I move ahead, next is the important thing is the step function. Okay. When we talk about the step function, so far we have learned about the Lambda. Lambda can do XYZ kinds of stuff. Lambda is very beautiful, very helpful, or it can help you to focus on the business application and all. But let's say you're working in a very business application, which is for sec is like a application approval, leave approval kind of stuff, right? It's a very simple application. But if you understand the application working behind the scene, it is very difficult, right? You as an end user apply for your leave, that goes to your manager, that goes to your HR team, then it goes to finance team. And then after the approval, you get an approval, right? I mean, ideally your reporting manager or your manager approves it, but there are notifications that goes to the HR team and the finance team to inform that, okay, out of the total leave, this person has encashed or this person has already took one leave. So the records get updated at their end, right? So such kinds of complex application, if you want to build with Lambda, how that's possible? For sure. Individually, you can have, let's say, 3 Lambdas. One, as an end user, you can make a request. Second, that Lambda sends another, there is another Lambda which is there for the HR team. There's a third Lambda which is there for the finance team, right? But have you thought through how you're going to connect this 3 Lambda as one function, right? Because it's very important that you connect these dots. If something goes wrong, let's say, for example, I don't even have the permission to open up the leave request, then what's going to be possible with the remaining 3, right? So you have to coordinate and have a more synchronization. Where exactly step function hits that requirement by providing a serverless orchestration service. So as you can see in the graph itself, right? Let's say there is a Lambda which gives a hello world. That, okay, is the input is hello world? If yes, wait for 3 seconds, then you split, then you merge and give an end, right? If the example is not hello world, then you directly end. Such kinds of decision making, orchestration, if you want to do for any enterprise critical application or any workflow kind of application, step function is a go-to tool. It blends up pretty well with AWS services. It initially started working very well with Lambda, but now you can see it blends pretty well with even SageMaker, EMR. And there are many other applications I've seen step function. And the way the services evolved over a period of time, it's fantastic. Like it's really good. Like you don't have to worry about the scaling part of it and all. You have to just provide your entire state machine, right? Which is called as Amazon State Machines, ASM. That state machine takes care of everything what you need to configure, right? Let's understand 3 important things about step function. The ASL language, Amazon state language, consists of 3 things, right? State machine structure, intrinsic function, common stage field, right? So first of all is the state machine structure. So state machine structure, you define somewhere in a JSON kind of a language where you say when it's going to start, when it's going to stop, what is the timeout and all. You try to configure each of your actions. So each of this step, you try to configure with help of a state machine structure. Then there are intrinsic function. Intrinsic function is more like, okay, for a very simple of it, here is an hello world, right? Now there is an hello world which which is like in JSON. You don't want to pass the entire bulky JSON to the second job. You only want to pass one specific key. Such kinds of intrinsic function can also be taken care without any line of code from state machine itself. Last, the simple passing on, right? The common state fields, like things like you need to pass the input, you need to get the output around it, right? It's all about the communication from one job to another. As we can see, this is like, it's communicating to the different step that, okay, hey, is a hello world example? Yes. If yes, then wait. After wait, the wait communicates to them that, okay, I'm done with 3 seconds. You can move on. After these two, it gets merged. It's more about the coordination and communication, which are done with with the common sets of fields like comment, input path, output path, type, next, and end. Right? It's a very common keys from the name itself we can understand. So there are three important things when we talk about the language. And for the stuff, for the step function, you have to provide the state machine, which makes it more serverless and orchestration and allows you to do the business application. Next, a very important thing, a very important services, and one of the oldest services of Amazon, SQS, right? Simple queuing service. This simple queuing service has multiple benefits of it. First of all, its name itself suggests it can queue the messages. It can a best service when it comes to decoupling, building a decoupled architecture, right? If you want to avoid back-to-back chaining of the things and want to take a pause and chain, right? When you're building any business application, it's very important that if one component fails, the implication should not be applied to the next one. There, SQS or queuing services helps better to break that effect. If one component goes wrong, it should not have an effect to another one. You should break it there itself without having the entire system failure. Such kinds of very complex things have been simplified via SQS. Also, it can help you the messaging part of it, that you put the message into SQS. There is a Lambda, other actors are there, or other consumer are there, which consume the messages and take care of it. So that's the benefits, or I will say business use case of SQS. Let's understand a couple of more details. SQS, need not to say, we are talking about serverless. So it's a fully managed serverless service, which is used to decoupled application. It can easily send from one message per second to 10,000 per second, right? It can easily scale and provide you the lower latency of somewhere less than 10 milliseconds to publish and receive. Publish and receive means, let's say I am the one who has given any input to SQS, and then some Lambda is sitting as a backend to consume, right? So between the time I upload the message and between the time Lambda downloads the message, it's less than 10 milliseconds. So that's very almost there as a real time in nature, right? The retention of the message is from 4 days maximum up to the 14 days. That means any message oldest can stay up to 14 days. After that, it will be automatically purged or in short deleted by the SQS. No limits how many messages you can store in a queue. Messages are deleted after they are consumed by the consumer. Once you process the message, it gets deleted, which is obviously. Consumers share the workload to read messages and scale horizontally. Very important part, I can help you how exactly this can be thought, right? Certain times what happens, right? Let's say, for example, Amazon sales, right? Prime Day. Now, there are many people who order it, right? Who orders around the Prime Day because there are discounts and all this stuff. At the end, they are doing a billing. And after the billing is done, you get a notification. A notification is sent to the warehouse for the procurement of the order and all. Similarly, a notification is sent as an end user to me to inform my order is successfully registered. Just think of it. In the Prime Day, there are 1 million or even 10 million or 100 millions of users are there, right? How exactly you can scale, because all those activities should be get recorded in the database. It's practically impossible that you can scale your infrastructure because you never can predict the load, whether it's the time at which this load is going to increase, whether it's going to be 3 p.m., whether it's going to be 3 a.m. There exactly SQS decoupled and ensure that whatever the traffic is generated, all those messages get captured into SQS. And as and when messages and scale comes horizontally, it reads and it scales. So that's the example of SQS, what you have and how helpful it is around. Next, what we have is the SNS, right? SNS is a notification service. Somewhere SQS and SNS works in hand-to-hand. It's more of a notification, and second was more of a queuing mechanism. Somewhere you will get mixed up that, okay, both lies on the same thing, how it can override, right? So notification is more from a different ways to handle notification. It's not just between the AWS service, right? The notification can be in form of email, can be in form of some notification, push notification to some Apple device or something, or it can be like an HTTP endpoint or even to SQS, right? It's a broader, not only just limited to AWS services, it can also reach out to humans. So that's a difference around it, right? The beauty of this service of SNS is, if let's say you have one message, which I was talking about, right? That when you apply a leave, that leave approval, which is done by your manager, should be informed to different actors, right? You, yourself, HR, and finance. How same message can be processed by three things, because SQ has already mentioned that once you process, I'm done. I'm going to delete it, right? Once it's successful. There exactly, SNS comes into the play. What happens when your manager approves the request, a notification is been sent by SNS to the different consumers, the different subscriptions. That's the right term what we refer in case of SNS, the different subscriptions. The subscription can be application to application or application to person. From the name itself, it is very clear. Application to application means from SNS to any AWS services. Application to person means from Amazon or from SNS to any of the methods by which a human can be or person can be informed. Things like emails and all other stuff, or push notification or SMS. Via which the same message from SNS can be fed to SQS, can be given to Lambda, can be given as a push notification. That's how you can publish to a broader way. The subscription kind of stuff, right? I subscribe something, then I'll get a notification when things are available. Simple example can be a wish list. Generally, when things go out of the market, out of the stock, you click that, okay, wish list, or subscription in YouTube, that, okay, wish list, whenever a new video comes into it, please inform to me. Such kinds of things comes in case of SNS. Whenever there is a topic, the SNS is only able to send a notification to you or any Amazon service if they have subscribed that topic. And again, there are certain limitations are there that, okay, it's about 10 million subscription per topic, around 100,000 of topics limited. Ideally, you will not worry about all the stuff. It's a very huge number, but majorly just remember, SNS has a very broader perspective, and it can reach out to not only Amazon services, but even to humans. SQS is more queuing, decoupling, and within the AWS ecosystem. So that's about SNS and SQS. Let's understand a couple of more details, like how exactly the invocation model works, right? So since we have learned so far from step function, SQS, SNS, and other stuff, right? In case of Lambda, execution models are of three types: synchronous, asynchronous, and poll-based. Synchronous is more like an API request response. I am an API. Someone hits me with a request. You go and execute Lambda. I request Lambda. Lambda processes that request, sends a response back to me, and I give it to my end user. That's a request response. Asynchronous is someone tells me, hey, you need to execute this particular message. I tell them, okay, and then I give it to Lambda. Whenever Lambda is in mood, it will just process and give me the response, which is asynchronous. You're not waiting for the end result. You know the end result is going to be done, taken care. And at the last is a poll push. I keep constantly hearing about it, that is there some change? Is there some change? Is there some change? And finally, when there is a change, I keep passing it to the Lambda, and Lambda keeps processing around it. Synchronize, asynchronized, poll-based. Synchronize can be very simple as you hit something, click on order. Let's say you go to Amazon, you click on order, click order, you take the payment, immediately you get an email notification. It's not an best example, but somewhere you can think of it. Asynchronized is, let's say you apply for some, let's say you apply for an Aadhaar card. You're not going to immediately get an Aadhaar card, right? They will make the registration for you. They will give you some time, some appointments. It's an asynchronized. Spontaneously, you're not going to get another. The poll-based is more kind of thing. You can think about the polling, right? You constantly keep voting around it. The voting, what we have, you keep constantly voting around it. At the end of the entire voting is done, the next day you will get the results of it at the consolidated way. I know this is a very poor example, but somewhere it will help you to understand how things work when it comes to the execution model, because this is very important when you're building any serverless application. I know this is pretty early, but this is a core one, that it's not just connecting different services of serverless and building in state, but understanding what is the nature of that application, nature of a particular component in an application, and then you design around it, right? Now, in case of, let's say, you pick up asynchronous, but the application has to be synchronized, right? The entire architecture will fail there and there itself, because even though you have choose the right Lambda as a service, but you will not provide the business impact, and the negative and the feel will be Lambda is not right suitable for this. But that's not the case. The problem is you haven't followed the basic principle of invocation model, what and when you should design. Moving towards the next, the different serverless architectures, right? There are different ways a serverless architecture is, continuing the discussion what we had in the previous. Simple of it, I upload an object to S3 and immediately Lambda gets triggered. Okay, that someone uploads it. The second one is the constant data that keeps happening, right? The data get published to SNS and from SNS to Lambda. The third one is around what you have is the entire polling, right? The message is there. The SQS keep polling these, Lambda keep polling the message from SQS to ensure, is there any new message? Is there any new message? Is there any new message? That kind of stuff. Generally, people, we do it, right? When we have our results, we keep hitting on refresh button. Is the results out? Is the results out? Similarly, Lambda is very excited and does the same thing. Keep constantly checking after every frequency what we have defined. Is there is a new message? Is there is a new message in the SQS? And if there is a new message in the SQS, it will consume that message, process it, and perform the action. So there are different ways, continuing the discussion what we had when it comes to the serverless application. Use cases, right? This is very important thing that, as I mentioned in the initial slides also, you need to be very good in deciding, is serverless a right service for you when it comes to the architectures, right? Otherwise, if you end up overfitting any of the non-serverless platform or architecture in a serverless state, the results are not going to be a good one, right? Sorry, give me a minute. So things like, as I mentioned initially, Lambda is very good when it comes to the short duration stuff, right? Let's say in case of web application, any sorts of notification, any sorts of API response, right? Microservices. There, Lambda is a very best fit to work around it, right? But similarly, think about an UI application, which needs to be up 24/7. You may or may not put that into a Lambda, right? Because you know pretty well, either your Lambda will be always up by 24/7, or you're going to burn out your Lambda. Second is the backend, continuing the same thing. In the backend, you can build a REST APIs, the microservice architecture, which is very commonly used nowadays. You can have your APIs and other REST APIs and other things hosted around it. Data processing. Very important thing. Please be very cautious about data processing around it, right? If you are consuming, right, things like IoT, or things like doing a larger data processing, right? If I be very precise, you have to process GBs of data. Trust me, Lambda is not the best use case for that, okay? Lambda is for the shorter duration around it. Just think of it, if you have 1 GB of data, how much time Lambda is going to take, or any compute is going to take in general to process, right? So please be mindful when you're dealing with the data processing one. Chatbots, best thing. You are doing around spontaneously, hello, my name is Sanchit. Hello, my name is Chatbot. It's a very continuous request response kind of stuff, right? Amazon Alexa and IT automation. IT automation, the same HR example, the leave application, what we talk about. So the different ways, these are very handful of applications or the demo, right? Honestly, the world has moved way beyond to this one. There are multiple different stuffs are there, multiple different examples around it. Like with the help of, one example I would say is, which personally also have built around that one is, with the help of container, you can deploy the Docker image in Lambda. People have started also deploying the machine learning models to it, right? They build an entire train model, have a Docker image around it, and they deploy that image into the Lambda and have very fruitful results and very high and efficient way of even deploying the machine learning, right? So these are the standard examples, but when it comes to serverless, people have taken it to the next class itself. The most important slide, which I love a lot about this entire session, is what is serverless good for? Okay, this is very important for everyone. There are many ways you hear about containers are best, Lambdas are best, right? Again, be mindful around it. I would say everything is best. There's nothing. Right from bare metal to Lambda, we learned multiple things, right? We learned bare metal, we learned EC2, ECS, EKS, as well as Lambda. We heard about all of these services. I would say, given in a current scenario, given the type of business application you want to build, all of these services are very good. There is a certain state of application. Based on that, you need to decide, given that a services works pretty well or not. Let's say if you bare metal also, it looks very painful, but ideally it's the best when it comes to building like any compliance application where you don't want to share your virtual, right? You don't want to go into virtualization, like things like banking and those. They want to be very proprietary to themselves and they want to adopt cloud. In that case, they cannot go to EC2. EC2 is a shared virtualization. Their bare metals is the only and the best way you can look forward to it. Second, talking about ECS and EKS. You want to build any kinds of state application, right? As we learned about the Lambda is more stateless. Stateless means that let's say you have two invocations, 1 and 2. What happens in 1 stays in 1. It doesn't overpass to 2. But let's say if you are running any machine learning algorithms, any main algorithm, any scientific algorithms, the core part or the thing about scientific algorithms are you need to pass the output from stage 1 to stage 2. Lambda is going to fail there. It's not going to work, right? So there, things like ECS, EKS works pretty well. And when it talks about the serverless, anything when it comes to chatbots, notification, microservices, media streaming, serverless is the go-to thing, right? So you have to be very mindful where and how are you leveraging your Lambda and for which business applications, right? I've written a handful of my experience around anything which around microservices, mobile backend, bots, IoT, ML inferences, or service integration. Lambdas are good to go. Things where Lambda fails, database. I haven't seen anyone deploying a database in the Lambda so far, and don't even try that. Deep learning models, not meant for it. Heavy duty streaming application, as I talk about GBs of data. Numerical simulation, scientific algorithms, which I talk about, video streaming. These are the things you should not even think about going to serverless. Because there, if you implement serverless, you may be able to deploy your application, but you're not going to get the performance, what you're looking forward. The cost is going to be much more higher. And then you will always feel Lambda are not meant for me. Because of this reason that you have not chosen the Lambda in the right way, where you should be doing around it. So it's not the problem of Lambda, it's the way that you have designed your architectures. So this is the core slide, I would say, in my entire presentation, where you should understand where and how you should use Lambda. Next, we'll do one more quick demo. I want to make you understand how exactly the event pipeline works here. So this way, we not only just understand a simple hello world, but we also go and understand how exactly the event things can work, okay? So I'll switch over to my AWS console. So this Lambda I've already deployed. I'm going to leverage the same Lambda, right? Because I want to focus how things work from a serverless perspective. So for today's demo, what I'm going to do is I'm going to play around with SQS. So I got my service SQS and the services section. Okay. So when it comes to SQS, there are two types of queues are available: standard and FIFO. FIFO ensures that whatever the message you deliver insert first will get delivered output first, right? In standard, there is no guarantee in terms of preserving the order. That is also more critical and based on the business application, right? That how you're deciding around that queuing. Like if you have some SLA application, then for sure you should go with the FIFO queue. And again, the visibility timeout, delivery delays, receive message, those are the different kinds of stuff you can add here, right? As we've spoken about, you can have 4 days, which is the default, to up to 14 days of retention. You can have the access policies. You can use the basic one. You can go to the advanced. Since it is a very basic demo, I'll go to the basic, what is there. You can redrive it, or you can do encryption. You can do dead letter. Dead letter queue is very important, right? It can help you in sidelining. Let's say, for example, you get an event. Now that event is corrupted, okay? Or the message payload is corrupted. Now what happens if you keep in a Lambda, if you keep in a normal queue, Lambda will always pick up, or your consumer is always going to pick up, process fail. That becomes like a chain, right? To avoid that chain, you can use dead letter queue that will sideline that corrupted message to another queue. So you can track and you can manually process it, right? You can define after how many retries, maybe 2 retries, maybe 3, maybe 10. After that defined retry window, you're going to sideline that message to another queue and you can manually read that message. So we have spin up a SQS message. This is a different way. You can give an SNS subscription. You can subscribe to SNS. So as we talk about right at the beginning, SQS and SNS works closely hand in hand. The application to application thing, what I mentioned. Similarly, you can subscribe to any SNS, right? So if you send a message to SNS, SQS will also receive it. But here we are more interested to understand how the Lambda works. So here from drop down itself, first you need to ensure that you're pointing to the right region. And from the drop down, you can select the existing Lambda. The Lambda which we developed is the serverless. I mean, both are the same Lambdas because one is from the drive end, but we'll go with the serverless step. And I'll click on save. As soon as I save, you will see it's creating a status. Once this is available or active, we will go to the Lambda or we'll try to publish a message here. So let me wait around it. And in meantime, what we'll do is we'll go to the monitor and I'll click on viewing the CloudWatch logs. Okay, so the console is loading around. So a minute. So this will directly take me to the CloudWatch log section. These logs are the Lambda logs, the Lambda which we deployed and we executed, right? The initial first demo, this is the same Lambda. So logs are going to be the same. I just want to demonstrate you that we have executed once. So you will only have one log. And as I hit a message in it, it will show you how exactly your Lambda got executed. Hello. Okay, sorry, I think there was some network. Check my end. Let me share my screen. Okay, so as I was here in the Lambda, right? If you go to the CloudWatch and you can see that, okay, the Lambda got executed. Immediately there were two message notification that was done, right? One was around the first initial demo what we had. Which we got start and then we got successfully added, right? The first one. This was a one which we executed for the one. And this was the second one, 22. The number one, where we give the number 30 and 40. So these are the two applications what we had. What the second one is the SQS, right? Now, if I refresh here, you will see the status is enabled. That means now the integration is all set. You can go to the Lambda and you can go and execute around it, right? What we are going to do in that case is, there are three functionalities are there: edit, delete, purge, send and receive. I'll click on send and receive. And I'll just paste this message. This is the same message. Intentionally, I'm changing the value of it. I'm giving 10 and 20 so we can segregate the message. Anyways, by default, it's going to be a different log. But let me go and hit around this. Your message has been sent and it is ready to receive. By the way, it's not ready to receive. It would have already been consumed by now. So as we can see, initially there were only two logs. The third log group is already created. And we can see the message event, which was shared or which was consumed by Lambda via event object. This is the message, right? After processing the message, what we have given this. This is how the real time, very real time, like by the time I just switch the tab itself, the Lambda already processed that event. And if we go here, and if I try to refresh the message count, you can see there are 0 messages available around it. Let me do one thing. Let me give one more message to it. Let me make it 70 and 80, some different value here. And send. Okay. If you go again, right? If I go back to the AWS console, the log, here you can see the message already got consumed in just like half a minute, and you get a different output to it. And if you go to the SQS board, if I go to the queue, so I inserted 2 messages. Since both the messages got successfully consumed, the messages are already deleted and the queue is empty, right? So this was a quick demo around how you can plug SQS and have a Lambda around it, right? The reverse can be, let's say for an example, if I talk about, let me give a corrupt. Let me try to make a fail case, right? Okay. So I've given a message which is number. And as you can see, the message is in flight. That means this message in flight means the message got already there in the Lambda. And you can see an error message that there is nothing key called as number 1, which was expected from the event. And by default, the message is in the flight. So flight means that the message got processed and it's waiting in a queue for a second attempt. And if you refresh it, this chain will come again. The message will be available. It will be picked up by Lambda. It will get failed. It will move into the flight. And flight means it's waiting for its next turn. After that flight, again, it will be active. To avoid this entire chain, as I mentioned, there is a dead letter queue that after, let's say, this 1, 2, 3, whatever the time you configure, this will move to the dead letter queue. So this way you ensure that your message is not getting dropped. If something goes wrong in the Lambda or the event, it's not getting dropped, as well as it's gracefully handled. So that's about this demo from SQS and Lambda. And that's about from this today's session. Thank you for joining today's session and hope you have a wonderful day ahead. Thank you.